All right, let's go through some example problems that show a few of these concepts that we've talked about and some of the errors that you can end up getting and how to correct them. The typical errors that we first make. And let's go back through and look at an example of declaring and initializing a variable. Let's go ahead and start up code blocks, because just looking at something on a slide doesn't always show us how to use it in our C environment. I'm going to bring code blocks back up. So if you've got your IDE up and running, right, you want to start it up or create a programming text file. All right. Here was our previous exercise 1. I'm going to go ahead and close this Actually, I'm going to go ahead and close this project. So let's close the project. No, I'll just save the changes. All right, I'm going to create then a new project. Let's create a new project. I'm going to call it an empty project. Hit the go. I'm going to call it. And when you create these project names, don't use special characters outside the underscore. So use your identifier naming rules for C whenever you're creating file folders or project names. So I'm going to call this C underscore fundamentals, since it's from our C fundamentals lecture. That'll store it on my desktop. Right, I want to debug and release. So now we've got this project, right, workspace. Here I've got my project tab. If for some reason you can't see your project tab, you can always go here to the view and actually then go ahead and enable the manager and the other tabs to make sure you can see everything. All right. But what we want to do is we have new code here. So we want to create a new C file. So file, new, file. Remember to choose C source file, go, C. And I'm just going to call this, I'll just call this example 1, example 01. We'll save it with the .c extension. I'm going to click all for targets. I always want to make sure I at least have the debug target. All right, back in our PowerPoint. So I'm going to shrink this down. All right. We went ahead and declared a variable x and assigned the value of 10 to it, and then it returns. Well, it's best not to copy code from a PowerPoint slide or from a Word document, because a lot of times it has other characters embedded in it. They aren't .txt files. They weren't made with a text editor, and they have embedded characters we can't see. So let's go ahead now and then just create our own program. So notice I'm not going to use a pound include here. I'm not calling printf. I don't need it. And we're going to start with main, int main void, left curly brace. Code blocks gives me the right curly brace. Return 0. And Control S to save. And I have a working complete C program here. Right? It doesn't do anything other than return 0 to the operating system. So we said, let's put in a comment here. Declare variable x. All right. Data type is int, right? And the name of the variable is x. So now we declare it. Let's go ahead and assign the value of 10. So x, assignment operator is the single equal sign. So assign a value of 10 to it. Semicolon to end the C statement. Control S to save it. Well, let's go ahead and go to the build menu, and let's just say compile. So compile just checks the syntax. And notice once again, because of the warnings I have enabled, let me make this bigger, it warns me that the variable x was set but not used. Right? Normally you wouldn't want to turn in homework or submit a program to a customer that had a warning in it. In this case, we're going to let the warning go. We simply want to see how this assigns the value. All right, so we had no compile errors. We're able to go ahead and build the program. So if I said build, it's going to go ahead and make that executable file for me that I need. Right. if I were to say run, what this does is it pops up the console window, it runs the program, and it tells me, well, that the process returns 0 to the operating system, gives me an estimate of execution time, and waits for me to press any key to continue. Notice we didn't get any output to the console terminal because we didn't use a printf. We have to use some sort of statement to print something out if we want to do that. And that wasn't the purpose of this. I'm just showing you this because a lot of times early on in programming, you'll just hit the run button and you'll say, why didn't I get any output? Well, if we don't print something out, we don't get output. So let's just hit the enter key to close this. And now let's use the debugger. So I'm going to place the cursor right here. And I can either go to the debug menu and say run to cursor, or I can right click and choose run to cursor. And I'm just going to say no, I don't want to save that. All right, now that this is run, remember we said this yellow triangle shows the next line of code to be executed, meaning all the code above it has been executed. Now, okay, this is not good because I didn't clean out my workspace. Notice it's not showing me anything for X, it's showing me everything from exercise 1. Let's stop this running. Let me go ahead and I'm just going to clean the workspace. And now let me rebuild. All right, got that warning again. Let's try right click, run the cursor this time. No, I don't want to save the default. Not very happy with code blocks right now. So let's see what I can do to get rid of this. So let me do build. Let me clean everything. Yes. Let me clean my workspace. And so the only thing I have in my workspace here under project is C fundamental sources example 1. Let's just go ahead and check that. And resources. Okay, these are just all the files on my system. Projects. We should be working out of this project. Let me try. Let's say I want to save the default. I don't know why code blocks is giving me this old one. I'm going to say delete all. Now my watch window's gone, so I'm going to go back to the debugging. So I went debug, debugging windows, watches. Okay, so for some reason it was still pulling in the information from our previous project. I just cleaned everything, and what seemed to do the trick is when I said I wanted to save the new default workspace, and I was saying no before, once I saved that new workspace, it stopped using the watch window from the last workspace. All right. Part of the frustration of working with this is learning the tools, and they don't always behave exactly like we'd like them to. All right. So here we are. Here's our yellow triangle. It says it's run all the code up until this point, so it has not yet assigned the value of 10 to X. All right, if we look here in the watch window, we can see the local variable X just happens to have the value of 68. That's whatever happened to be in memory. All right, but now if I choose next line, so next line will execute this very next line. So if I click on that, it took the value of 10. If you look here in memory, right, here's X, and it stored the value of 10 in memory. So we can see then we saw in this case this had a garbage value of 68. But when we actually executed this assignment, we initialized X to 10. And now if we were to work with X, we know it has a known value of 10 in there. All right, so that's what that example was all about. All right, let's look at one of the common errors, using a variable before we declare it, right? I'm going to show you some common mistakes that you're going to make. These slides are here to help you go back if you make this error and have a way of determining what it is. Let's go back now and change this program. So we said then that a common error is using a variable without declaring it. So I'm going to delete our declaration. I need to stop the debugger running from before. All right, now, whenever we make a change to a program, we always have to recompile and rebuild. So notice now I went to build and I chose compile, and we get this error, error X undeclared. So whenever you see this error telling you that one of your variables is undeclared, that means you're using it without declaring it. So if we went back here and put in what we just had before, int X, if we put that declaration back here, so let's go back to build and compile. Notice we got rid of that error. We're back to the warning about X being set but not used. And everything's okay because we've declared it. Now, let's go ahead and let's cut this and let's move this down below. We're going to get an error here because here we're using X, we're assigning the value of 10 to X, but we haven't declared it, right? X does not come into being until it's declared down here. So let's go ahead and build, go to the build menu, compile, and here we get the error, error X undeclared, first use in this function. Right. So we look and we say, well, X has been declared, but it's been declared here. The compiler goes through your code in order. It looks at this line, then it comes down and it evaluates this line. It has not yet read this line, so it doesn't know that you're declaring X later. So you've got to declare it before you use it. All right, so here was our example here where we used X without declaring it and got a compiler warning, error. Okay, let's go to case sensitivity and illustrate that small x and capital X are not the same. Notice here that we declare the variable X as a lowercase, but we're using X as an uppercase here. Let's go over here to code blocks. Let's cut and paste this back up above so that it's properly declared. And let's use this capital X here. All right, so we're declaring this as a small case X. We're using a capital X here. So let's go to build, let's go to compile, and it tells us error, capital X undeclared. Right, so now if you look at this and you say, well, what do you mean X is undeclared? I declared X here. Well, then start looking for different spellings or case sensitivity. Right, and if we were to change this back to the small x, build and compile, that error goes away because X has been declared. One other thing I want to mention is notice as we've been working with code blocks has been automatically indenting for us. We indent things on similar levels. At this point, we only know one level to work with. But we go ahead and we follow this style. It makes the style easier to read. So when you write code for this class, you need to follow good programming style. And if you want to control the number of spaces that this indents, you can always go to settings, go to the editor. This is the text editor. And here on tab indents, you want to have that turned on. But if you want to change the tab size, if for some reason you want it to always indent 5, you can make that a 5. I happen to have this set to a 3. I happen to like 3. Right, but just make sure you have some sort of indentation there. And you can say OK if you wanted to save it. And so then code blocks just automatically indent. So when we write code inside of a function, we always indent here and have everything on the same level. Later when we start writing if statements and loops, we'll find out that there's a good style for indenting the code that's contained within it. And so follow that style. It's easier to read than if you were to just put everything over here to the left. This makes your code more difficult to read. Not as bad when they're just 3 lines, but when your code gets longer, it just gets very difficult for us to read. And good programming style says don't do that. Your customer generally won't see your code, but your other customers, your coworkers, people that have to maintain this would not like this, and it will lose you points when things are graded in this course. All right, so follow good programming style always. All right, let's see what other examples that we have here. Case sensitivity. We just illustrated that. Okay, here's an example then. If you were given a problem that said write a C program that declares a float variable named x and stores the value 169.74 in that variable's memory location, here's what I'd expect you to write. So it says write a program, write a C program. So that means you need the entire program, int main. Notice we left out the void here. That's okay. You need the left and right parentheses. These are tokens that indicate to the compiler that this is a function header. You need the left starting parenthesis, curly brace, ending curly brace here. And you can do this on one line or multiple lines. Here, just did it on one line, declared data type float, because the problem tells you right here what the data type should be. It should be a float. It tells you the name of the variable x, and it tells you what to assign to it or store in its memory. So it's a relatively simple program, but it does everything that you were asked to do in the problem statement. All right, here's an example with const then. All right, we want to write a C program that declares a constant integer variable named max rows and stores the value 10 in the variable's memory location. So a constant integer variable. Using that word variable here means you need to create something that's going to be stored in memory, variable, max rows. This is how we know not to do a preprocessor directive, because we need a variable, right? So we use the keyword const. We use the data type int, the name max rows. We said by convention, we make constants all uppercase, and we assign the value of 10 to it. Right. We do int main, we write that because we're asked to write a C program. Right. Let's go ahead then and do this back here. So we've got our int main. I'm just going to delete this, and we're going to say const int max rows is the name of the constant. We're going to set it equal to 10. And let's just go ahead and build and compile. Right. It's giving us a warning that we have an unused variable. We'll ignore that for the sake of this example. All right, but we've got no errors. Let's see what happens if later in code I tried to say max rows. We tried to set it to a different value. Max rows equals 5. The keyword const here says that this must stay the same throughout our program. So now if I say build compile, we get an error message. It says in line 5, right here, error, assignment of read-only variable max rows. So the compiler will give you an error and not let you proceed because of this keyword const says you cannot change what's stored in there. Now, example 4. Write a C program that declares a macro. So a macro is a preprocessor directive. Name max rows of integer value 10. Create a variable named rows and store max rows in that variable's memory location. All right, so let's look at this. Our problem says declare a macro named max rows. So a macro is a preprocessor directive. We know that our preprocessor directives go at the top of our program. And we use a pound define to create them. So pound define max rows 10. Create a variable named rows and store max rows in that variable's memory location. Well, actually, let's go ahead, bring code blocks back up. And let's paste in a comment here. So let's put our problem statement in here in the form of a comment. And I'm just going to use a multi-line comment. And I'm going to separate this out into actions. There's 2 sentences here. And I'll end the comment there. All right, so write a C program that declares a macro named max rows. So we said that our macros are preprocessor directives. So pound define max rows. We know the name. We know the pound define because we said macro of integer value 10. So we just put a 10 out there. Remember, we don't end up with a semicolon. We don't use the assignment operator. That is this part of the problem. The next part, create a variable named rows. All right, so we're going to do that inside main. We're going to create a variable named rows. And the name of the variable is rows. I want to assign something to it. I want to assign max rows. But when I declare a variable, I have to give it a data type. We need to make it match the data type of this. So this is a literal. Remember, it's a constant literal, and its data type is integer. So the data type for rows should be the same, int rows. And now if I want to store max rows in this variable's memory location, max rows. All right, let's go ahead and compile. All right, no errors. Let's go ahead and do a run to cursor here so it'll build. Let's bring up our watch window, debugging windows, watches. So notice here, rows got assigned the number 10. So what the compiler did is it took everywhere it saw max rows. So here it saw max rows, it substitutes in the value of 10 and stores that in rows. Notice here, under locals, we only have this local variable rows. There is no memory allocated for this macro, which is different than the const value that would actually have memory located for it. So let's actually go ahead. And what if we were to get rid of this macro? Here. So let's comment this out. And let's then say const int max rows equals 10. Let's go ahead and do a run to cursor here. All right. So I had to go ahead. I did a run to cursor. It has not executed this statement, rows equals max rows. But it did execute this statement. See here in our watch window, we have in memory now this constant variable, max rows. It has a value of 10. So it has memory. Remember when we had the pound defined, it did not occupy memory. But here, this has memory that's local to main. We can use that anywhere in main after we've declared it. Right, now if we go ahead and hit next statement, next line, that took max rows. So it went to where max rows is stored in memory. It got the value of 10, and it stored that in to our variable, excuse me, rows. So notice rows now has a value of 10. All right, let's close that down. And let's go back to that. All right, that was the end of our examples. Last topic of this lecture is on tokens. Tokens relate to how a compiler knows how to read the code. So it's a basic element recognized by the C compiler. And a C program is nothing other than a series of tokens. They're groups of characters that can't be split apart without changing their meaning. So identifiers that we create, keywords, operators, punctuation marks, string literals, these are all tokens. But usually this amount of space, so blank space is white space. So anything we call space, white space, is a blank space, hitting the space bar on your keyboard, a tab right? A horizontal tab, a vertical tab, hitting the enter key for new line. Those are all examples of white space. So usually you can have all the white space you want between tokens. So let's take a look at this statement, printf hello world. When the C compiler reads this, it breaks everything down into tokens. So we want to know how many tokens there are in this statement. The first token is this identifier. This identifier is the name of the function, printf. So here's one token, printf. The next token then that the compiler looks at is the compiler keeps reading all these letters. Notice there's no white space between the F and the left parenthesis. But the compiler then reads this left parenthesis and says that's a special token. So it counts this left parenthesis as a second token. Right? After that, it knows then it's going to look and it sees these double quotes, and the compiler knows that string literals go in double quotes. So it actually goes ahead and saves these string literals inside of a double quote. And it takes that as a string literal. Right? So hello world, the string literal is a third token. The fourth token is the right parenthesis. The fifth token is this punctuation of a semicolon, letting the compiler know that that's the end of a statement. Then the compiler can go back through and put these tokens together and recognize that this is a function call. Right? So let's look here at this printf here. We still have the same number of tokens even though the string literal is smaller. And here, when we have white space between the printf and this parenthesis, white space, blank space between here, that's okay. The compiler knows it. So each of these statements are the same. They have the same number of tokens. What's not the same, though, is you cannot put white space here in the name printf. Printf is the name of our function. When the compiler sees this white space of PRIN, blank space TF, it thinks this is a token, this is a token. So now it thinks this line has 6 tokens, and it will issue a warning. Right? So you do have to be careful where you put white space. So don't break up identifiers with white space in the names. All right, now we've come to the end of our lesson on C fundamentals. Here's a brief summary of the important things that we covered. Comments. You'll always be using comments in your code. Good programmers always include meaningful comments. I want you to go through these slides, study this. We covered a lot in C fundamentals. These summaries indicate the important points. What you need to know at this point is that you will be using these concepts for the rest of the semester. You don't need to memorize everything in these slides. There was a lot of information. We're going to learn how to use this information. In a few weeks, this will become second nature to you. So I want you to pay attention to the summary slides. These are the important topics. So you should know then how to create both styles of comments. Keywords. I made a list then of the keywords that we've seen so far. So you should keep a list of these keywords. If we were to have a quiz and you were to be asked on keywords, these were the keywords that would be covered in terms of knowing that they're a keyword, right? They're all data types here: int, short, char, float, double, long. Return, it goes at the end of main. It's not a data type. Signed and unsigned tell us whether things can be positive or negative. Void, that is a type as well too, right? That requires no memory. And const tells us that identifiers must be kept constant. So just recognize that these are keywords at this point. Identifiers. What you should know then is you should memorize. As I said in the earlier part, memorize these 4 rules. Memorizing them allows you to create them correctly without going back and looking them up. So memorize these 4 rules. We will be creating identifiers for the rest of this course. It will become easy for you, but if you have to go back and look up everything all the time, it will slow you down. So I ask you to memorize these 4 rules. One of the best ways to memorize something is to read it out loud, write it down, say them out loud. So read them, write them, say them out loud. Right? And don't try to cram it on the same day. Make a flashcard with this. Make some notes with this. And say it when you're, walking around campus, when you have time, and until you get to the point every day where you can remember this. Data types. So here's some questions you should be able to answer in terms of data types. These are important to know at this point. So go ahead and answer these questions. Variables. Remember that variables have to be declared before they're used. When we declare a variable, remember that it has a data type and a name. That's its general form. And importantly, the fact that uninitialized variables contain garbage values. C does not initialize them to some convenient number such as 0. So remember that they have garbage values if we don't initialize them. Constant literals. Be aware of the fact of the data types for integers and for doubles, and that you can change them. You don't have to remember at this point the U and the L and the F. These are things you can go back and look up. Go ahead and familiarize yourself with the ASCII table. So go ahead and practice answering these questions. They're good questions to have a basic knowledge of. Right? Constant literals here as well answer these questions about the base, and you should be able to then go back through the slides and review and tell me what is the difference between using these two. Right. ASCII, you need to have an idea of how characters are stored in a program's memory. Don't memorize the ASCII table. If you ever need the ASCII table in this course on a quiz or a test, you will always be given a copy of the table. So that is not something you should memorize. Just be aware of ASCII. Right. All right, that is the end of this particular lesson on C fundamentals. As I said, we'll be using these concepts and expanding on them all semester. Pay attention to what's in the summary slides. As you go through this lecture, when you have questions, go ahead and post your questions on the Canvas discussion forum. Other students will answer your questions. The TA may answer your questions. I'll answer your questions. But anytime you have a question, write it down. The fastest way to get it answered is to post it out on a Canvas discussion forum. You have an opportunity to ask in class, but there's limited time in class. You have the opportunity for office hours as well. So general lecture questions, I would always first try to get them posted on Canvas. If you need more clarification, please do ask in class or in office hours. All right, happy studying.